Hello everybody. In this video we will discuss ring opening reactions of an epoxide in basic conditions. We will not go over stereochemistry in this video. I will go over stereochemistry of this reaction in our next video. So we will focus primarily on the actual reaction mechanism. So let's start here. So if we have an epoxide, and we know how to make epoxide in our previous video. So let's go over here. So we have a nucleophile right here. So nucleophile has a negative charge. Now this nucleophile could come and attack here, or this nucleophile come and attack here. Now where it would go? It would go towards the carbon atom that is least crowded. So let's draw it out. So it will attack on the least crowded carbon atom. So least crowded carbon atom. Attack on the least crowded carbon atom. Now when it does, now the CO bond will break open. So this bond over here will break open. So what is the net effect we are getting here? So we are getting, so now you got O minus, and we got two of the methyl group right there. And then our new incoming group, the nucleophile, is attacked here. So that's where things are right now. And then the final step of this reaction is where you gonna neutralize the reactions with H3O plus. Basically what you have to do is you add some acid so that it will add proton right here so that things will be neutralized. So let's draw the mechanism here as well. So we got HOH H plus. So this would abstract the proton and the oxygen would be neutralized. So now we end up making OH, and then we have our nucleophile. So this is the actual reaction that happens. So now we can use any type of nucleophile we want. So let's try to draw a couple of problems here. Again, the goal is here not stereochemistry. Goal here is to figure out the product. We will talk about stereochemistry in our next video, so you should see the part 2 of this video sessions. Okay, so let's say we have a something like this epoxide. Maybe I'll draw a better one. So let's say we got this epoxide, and we treat with CH3 MgBr followed by H3O plus. Okay, so what would be the product of this reactions? Let's focus of this problem on the part 1. Okay, so I will add this one later. So let's see what would happen when you have CH3 MgBr. So when you have CH3 MgBr, this would react as if, so CH3 MgBr would react as if this is CH3 minus. So all the Grignard reagents that you have, organometallics, so you're going to have a negative charge on the carbon atom that is connected to magnesiums, okay? So if you have something like this, MgBr, then you're going to have a situations where you have 1, 2, 3. So you're going to have a negative charge on this carbon atoms, right? So just keep in mind, it's on the negative charge is going to be on the carbon atom connected to magnesiums. Okay, so that's the organometallics compounds. Okay, so let's move over. So CH3 minus would go and attack where? It would attack the least crowded carbon atom. So this carbon atom is least crowded because if you notice, it is connected to one carbon atom. This one is a primary carbon atom, whereas this one is a secondary carbon atoms. So attack on the least crowded carbon atom. Okay, so now I will add another piece of information the attack always happens from the opposite side of oxygens. So this is kind of an SN2 attack. If you think about it, it's always happens on the opposite side of oxygen. So that's gonna come into play when we draw the stereochemistries. Okay, so here, so what would be the product? So this electron here would move towards the oxygen. So the product that you'll be making is gonna be here O negative, and then our methyl group get attached here. Okay, so we have added a methyl group. If you want, I can draw the methyl group here, CH3. So that's the group that came in and attack. Okay, so that's our CH3 minus. And the final step of this reaction would be we will neutralize the reactions O negative ions by treating them with a source of proton. Again, any proton source would be fine. Basically, we are just dumping some acid to the reactions. That should be the final work of for this reactions. And bingo, we got our product. And you notice the incoming group is always on the opposite sides. Okay, so let's do another problems. Problem third. So what if, again, we are not focusing on stereochemistry yet. We are focusing only on the reaction. So what if you have this, you treat them with MCPBA, and then you react them with something like, let's say, sodium borohydride, followed by H3O plus. Okay, so what would be the product in each scenario? So if we know that MCPBA would make an epoxide on our alkene double bond, so we will make an epoxide. Okay, so that part is good. Now sodium borohydride. So sodium borohydride, if you see this type of sodium borohydride, or sometimes you might see lithium aluminum hydride, your life would be a lot easier just if you imagine. So this would react, both of these, okay, so would react as if H minus. So H minus, the hydride minus the hydride ion is your nucleophile. So hydride ion is your nucleophile. Is your nucleophile. Okay, so where do we get the hydride ions? If you look at the structure of sodium borohydride, it's sodium plus and BH, H, H, H. So there is a negative charge here. So now one of these hydrogens with the lone pair will act as a source of hydride ions. So basically, I'm just putting, again, I could use any one of them. So this would act as a source of hydride ions, source of H minus. Okay, so same thing happens with lithium aluminum hydride. So if you look at here, so lithium plus aluminum H, 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 and there is a negative charge here. So one of the hydrogen will act as a source of hydride ions. Okay, so let's see. So we have our hydride ion. So where would this hydride ion will attack? Because both of the carbon atom are equally crowded, so it doesn't really matter where you are going. So we could have make it more complicated example to make it more obvious, but it doesn't really matter. So it's attacking on the any one of the carbon atom. I could have gone here as well. Okay, so let's draw the product that would happen here. Okay, so we got our O negative, and then our hydrogen is attached here. Again, you don't need to show the hydride ion if you don't want to, because we are drawing line angle structure, but I am showing you for a reason so that you know that the actual hydride actually attacked. Okay, and the final step of this reaction is we neutralize it with H3O plus, where the negative charge here on oxygen will be neutralize. And that's it. That is the problems. We finished it. Again, you don't want to show the hydrogen. That's fine. If you want, you can. Okay, so that's the final answers of this set of problems. Okay, we will talk about stereochemistry in our next video.